Lesson 3.6 on page 175 using the quadratic formula and the discriminant. So we're still on parabolas and quadratic equations, which could take the form ax squared plus bx plus c equals 0. You're trying to solve for x. You got x squared here, not squared here, and maybe a constant thrown in the mix. Okay? Now, all along, but this entire module, you actually could have always used this to solve it. There are different ways. There's like completing the square and like, putting this in the vertex form. There's lots of different methods all throughout this module. But you could always use this. Like if you're really stuck, like, oh, I can't factor this, or this is like tricky numbers. Uh, so I do recommend that you guys memorize this. I won't force you to memorize it like for the midterm or anything like that, or for any quiz, but it is handy. Like this will solve all these, so it's really good to know. So anything that's in this form, x always equals negative b plus or minus square b squared minus 4ac, all divided by 2a. That's it. Okay. Now, what do they mean by the discriminant? That's one part of the quadratic formula. It's just as b squared minus 4ac, that the part that's underneath the radical. And why that's going to be helpful is because if this is positive, you'll get plus or minus 2, one of two different numbers. Okay? So you'll get two real answers. Okay? And that corresponds to, in terms of a graph, that would look like the parabola crosses the x-axis at two places because you're setting equal to 0, right? Whereas y equals 0, well, two places, okay? Or if the discriminant itself is equal to 0, this b squared minus 4ac, if it is 0, plus or minus square root of 0, well, there'd be only one solution. So that'd be like if the vertex just boink, just touches the x-axis, so you get one solution. Okay? And if the b squared minus 4ac is a negative number, well, you're not allowed to take the square root of a negative. Right. Well, not for a real answer anyway, maybe for imaginary answers. What that would look like on a graph is where the parabola is not touching the x-axis at all. Okay? And so that's how this discriminant is going to be helpful. I do want to point out too, this is my own extra little note here. Okay. Remember the last few lessons, it's been helpful to locate the vertex of a parabola by, say, in standard form, doing negative b over 2a, right? Negative b over 2a. So that's the x location of the vertex. It's at negative b over 2a. That actually kind of shows up in the quadratic equation too. It's right here. Boink. Right? So negative b over 2a. See that right there? And then plus or minus something. Kind of branches out from there. So much to the right, so much to the left. Maybe you get different solutions. All right. So with all that, let's take a look here. So first question is actually a physics question. So it's height as a function of time. You guys have seen lots of these, but throwing balls and fireworks, and you guys were launching balls off the balcony the other day. Right, so we got height as a function of time equals. Okay, now, the fact that there's negative 16 t squared, I know right away this is in feet per second squared. That's what that would be. Right, so we're in American type units plus 124.4 t. Right, so 124.4 feet per second is the initial speed. Maybe we're launching these pumpkins like straight up and right, plus 42. The plus 42 tells you the initial height. Right, so at time 0, maybe it was on a 42-foot cliff or ledge or something like that. Right, so what do we want to find? They probably want you to find um, say quadratic. Oh yeah, set it equals 0. So maybe like where is it hitting the ground? Now what could really be helpful is if I draw a picture of this. So here's what I imagine. Imagine it's kind of similar to you guys' projectile lab, where you guys remember you had that launcher and you blasted the ball and it right, landed somewhere way down here. Okay? And you were supposed to figure out how much time did it take. Actually, no, this is exactly the same thing. Yeah, right, except this is in feet instead of meters, but otherwise it's the same thing. Okay? And so uh, the initial component of vertical, the initial vertical component of velocity is this number right here, 124.4. This negative 16 has some, it's related to Earth's gravity. And this 42, that'd be like this initial height right here is 42 feet. Right, so that's how these numbers correspond to this picture. Okay? But yeah, you can just jump straight to t equals, go negative b, so negative 124.4, plus or minus the square root of b squared, 124.4 squared, minus 4 times a, which itself is negative, careful about that, and then c is 42. Okay? So I have all this underneath the radical, and then furthermore, I'm grouping all this in the numerator, and that's all divided by 2a, so 2 times negative 16. Okay. Right. Yeah, one thing I might do if I'm plugging this in the calculator to help myself out a bit, I do see a minus here and a negative here, and it can become plus positive. So I have nothing negative in the radical, right? So this is going to be a positive value, which means square root, I'll get plus or minus, right? So there could be two values that come out of this. Okay? And there are a couple of negatives here, watch for that. Now, I know definitely from the picture also, if I complete this parabola, wouldn't it kind of go like backwards in time is what this pink part of the parabola would mean? And the this pumpkin is not at the ground backwards in time. That doesn't really make any physical sense, but it would be forwards in time. So I bet you get two answers out of this. One that's positive, like very big positive, which would be the actual answer. One small negative number. It was the same thing when you guys went on the balcony with the launchers. Right? Same exact same story. Now, since this is one of their examples, I'll go ahead and just cut to their work. And oh, actually, you know what? They only got that far. Here, I'll go ahead. I thought they might have the answer, but I'll go ahead and plug it in the calculator. So we got negative 124.4. Let me start with plus just to see what happens. No, take one around with it. Square root. Notice I've already opened a radical, or sorry, no, open a parenthesis for the numerator because I've got to group the numerator together before I divide. Okay, be careful about it. If you have a lot of trouble plugging, uh, correctly communicating with the calculator, it's okay to chunk this into smaller steps. Like just calculate this bit and then write that down, and then calculate this bit and write that down. And then, okay, you can do it. But I'll show you how to correctly put it all in the calculator in one go. So got square root open parenthesis, 124.4 squared. Now this is plus plus, so I'll go ahead and just continue its plus. So plus 4 times 16 times 42. Now this closed parenthesis closes the radical, and this closed parenthesis closes the numerator. Then divide by, is it okay if I call this negative 32? Is that okay? The negative 32. All right, so I'm getting time equals, yeah, just like I was predicting, there's a small negative value, negative 0.32 seconds, which doesn't really mean anything because that's like back here. So we're going to throw that one out. I'll say, or you get the actual answer. Actually, all I have to do is scroll up, scroll over, and where the plus was, just replace it with a minus, and I should get the actual answer, which is, there it is, 8.10 seconds, it rounds to. Yeah, that looks about sense, right? I mean, if your velocity is about 124 feet per second strictly upward, right, it's going to be the air for what, like 8 or 10 seconds before it's the ground? Yeah, there you go, exactly. From 42 feet up for that matter. Okay, so there you go. And pretty much all the questions in this lesson are going to follow that format because that's the quadratic equation right there. All right, so we got example two. So that was example one. Example two on the next page. See, real roots c is negative. Well, okay. X squared plus 4x minus 17 equals 0. Okay. Let's just go to this. So we're solving for x. Right? I can see, like if you were given this out of context, you thought, see, could I factor that? What are two numbers that multiply to negative 17 and add the 4? It's not very easy. You can sit here, guess and check all day. So after a while, it's like, okay, you know what? And I'm again guessing and checking on how this factors because it doesn't factor very nicely. So I'm going to set up a quadratic equation. So x equals, set up a big old fraction, negative b, set negative 4, plus or minus the square root of b squared, so 4 squared, minus 4 times a. Isn't there an applied 1 right here for a? So that's a is 1. And then, now c is negative 17. I think the whole purpose of this example is to have you watch your negative footwork stay at minus a negative here. Okay. Then solve the numerator, then divide by 2a, which is like 2 times 1. Okay. So here, I'll go ahead and just get rid of those negatives. So let's see the plus right there. There's the 4. Open parenthesis for the numerator, negative 4 plus root 4 squared plus 4 by 1 by 17. Close the radical, close the numerator, divide by 2. So I'm getting x equals, well, okay, 2.58, or then scroll up, scroll over with a minus negative 6.58, right? So both those answers will work. So if I was graphing that, say it would, I know it's going to be an upward parabola because I have a positive on the x squared. Okay. So negative 6.58 might be here, 2.58 might be about here. I'm just kind of eyeballing it. And then you have a parabola that basically does this. So that'd be your parabola. Okay? And that equal to 0. That's the two places to cross it. Okay? Now the book, actually now I'm looking at how they did it. They went ahead and left the radical. So they have -2 plus or minus square root of 21. Now that's an exact answer. And let me show you that's also my decimal approximation should be the same thing. -2 minus the root 21. Yeah, that's that one right there. And then scroll over plus. Yeah, that's exactly that one. Okay. So I have a decimal approximation to the nearest hundredth, and then they have the exact answer as a radical. Okay, but that's a set. Okay, now example three, they got complex roots. Okay, so you guys remember we're about to run into an imaginary number I. You guys remember, see example three, quick review here. Do you guys remember I is the square root of -1, which the calculator can't do. If I try that, like, hey, what's the square root of -1? It's like, come here, So we'll just call that I. Here's another review. If I square that, that is -1. If I do it to 3, well, that's I times I squared, which, by the way, is -I. I to the 4 is 1, and then it's a 4-part pattern. Anything after that, it's just 1 times something. Okay. So what do we have here? We got 5x squared plus 8x plus 11 equals 0. All right, solve for x. Okay, so looks quadratic. Got an x squared, got an x. Okay, maybe sit here and try to factor it, and that's not really working. So, okay, no, I'm done trying to factor it. I'll just go ahead and run to the quadratic equation, which will always tell me the correct answer anyway. So x equals fraction, got -b, that's -8, plus or minus the square root of b squared, so it's like 8 squared, minus 4a and c. Okay, I got all my parentheses correct. This is all divided by 2a. So 2a looks like that. All right, and right now I know this one's going to be a little special, so let me do this. I'm going to break this apart into two fractions. Okay? So you got -8. Oh, can I say 2 times 5 is 10? Okay, 10. And then plus or minus. Now, this other fraction will still have a denominator of 2 by 5 or 10. Okay? But this radical, what is this? What is 8 squared minus 4 by 5 by 11? That's like -156. Okay, so I got the square root of -156. Okay. The square root of a negative, I know that there are no real solutions. There's only imaginary solutions. And then plus this other, remember what that is real, that makes it complex, a complex number. Okay, so what is root 156? Well, let me make a little factor tree over here. A little thought bubble over here. Thought problem. What does 156 break down to? I think it's multiple of 4, isn't it? Yeah. Okay, so it's 4 times 39, and 39 breaks down. I think is that 3 times 13? I should know that. Yeah, it sure is. Now, 3 and 13 are both primes, so can't really do anything with that. But the 4 actually is a perfect square, so I can pull that out as a 2. Ooh. So I'm getting x equals -8 over 10, plus or minus. And this works out to be, okay, I can take out this 4. Square root of 4 is 2. That's where I'm getting the 2 from. This negative underneath the radical comes out as an I. And then I'll have the square root of, well, and I still got the 39 left over, or the 3 times 13 would be like, I can't do anything with that. And then it's all divided by 10. Now, there is at least one more simplification I can make. I can reduce each of these fractions. These are even numbers, Okay, can I say x equals 8 over 10? Does that reduce to 4 over 5? No, it's negative still, of course. Okay? So divide by 2, divide by 2. Okay. Then plus or minus, and then this also reduces. So I times the square root of 39 over 5 also. Okay. So remember, because this is plus or minus, I'm really getting two different solutions. We get this minus this, or this plus this. Right, that's two different solutions. I see what you put did over here. Okay, you got -4, plus or minus I root 39, all divided by 5. Okay, they left it as one giant fraction. We just kept the denominators as 5. Okay. I have two fractions, it's the same thing. Okay, so there you go. That will be the answer right there. All right, the discriminant. Okay, so this is what I was telling you guys from the start. Is here, I have my notes right here. All right, so if this is the quadratic formula, then the part underneath the radical, the b squared minus 4ac, they're calling the discriminant, and that tells you how many real solutions there are. Okay, so if you do b squared minus 4ac and it comes out positive, that means there would be two real solutions. So let's say the parabola crosses the x-axis twice. If you do b squared minus 4ac and you get exactly 0, well, the square root of 0 is just 0. Whether you add or subtract it makes no difference. That means that you'll get one real solution, and the parabola on the graph that will just touch the x-axis one time, right at the vertex. Okay? If you get a negative number for b squared minus 4ac, like we did for example 3, that means that there are no real solutions. There are imaginary solutions, but no real solutions. And as a graph, the parabola would not touch the x-axis at all. All right. So let's try this for example 4. Should be lead into example 4. Yeah. Okay, we got so example 4. Got 2x squared minus 10x plus 7 is all equal to 0. Okay. So solve for x. Yeah. You guys notice these are all set equal to 0. We're trying to solve for x. Like, that's to say, like, where would the parabola cross the x-axis? That's another way to think of it. Okay, so now they're leading us towards the discriminant. So maybe I'll just look at the discriminant. So I'll say discriminant is b squared minus 4ac. I'm just looking at that one part of the larger quadratic formula. And so that'd be like, now negative 10 is being squared, which even if it's negative, that doesn't matter for the squared part because it'll become positive regardless. I mean, squared is always positive. Then minus 4 times, okay, here's 2, and your c is 7. Okay? So this is equal to 100 minus, no, 4 times 2 is 8, times 7 is what, 56? I think that's 44, right? Okay. But the important thing is that it's positive. So I'll say greater than 0. Positive, which means there should be 2 real solutions out of this. Is that what they're leading? Oh, okay. Yeah, 100 minus 56. Okay, so it has 2 real roots. Right? Okay, so example 5 says discriminant complex roots. So this one should be imaginary. Let's see if it comes out that way. Example 5. So got negative 5x squared. So I know if I graph this, I'll get an upside down parabola just from that alone. Plus 10x minus 15, okay, and then equals 0 to see like where we cross the x-axis. I think okay, solve for this x. Okay. Again, just the discriminant bit. Discriminant is just the b squared minus 4ac bit. Okay? So for our purposes, that'd be here's b, which is 10 squared minus 4 times. Now a is negative 5, so careful about the negatives. And then c is also negative, negative 15. Okay? Well, if I have 3 negatives, then overall it's still negative. Like these two cancel, it's still negative overall. So that's 10 squared is 100. So I'm still subtracting. Well, here, I should do this mental math. But yeah, okay, 300. Right. So the discriminant comes out to negative 200. And the important thing is that it's a negative number at all. All right, so I'll say less than 0, right? Which means I'll get 2 imaginary solutions. And so is that what they're looking for? 100 minus 300. Yeah, 2 imaginary solutions. Okay. Okay. All right, let's jump into the book questions. And so I highlighted some of these, and I glanced at the answer key ahead of time to make sure I was getting sort of different kinds of answers. So maybe some of these are real, some of these are real but irrational, some of these might be imaginary or complex, you could say. I got some word questions. Okay, so kind of a mixed bag here. Okay, number 1, got x squared plus 8x plus 15. Okay, equals 0. Yep. Okay, so I solve for this x. Okay, so I'm going to let's see. Actually, what? Don't think of it. You could factor this, couldn't you? Here, no, that's not the theme of this lesson. But I wanted to remind you that that's a totally valid thing to do. Could you say x plus 3, x plus 5? I mean, I just saw that right away because I'm thinking, what are two numbers that multiply to 15 that add to 8? Because if you FOIL, F O I L. So I already know that x is like, what would you need x to be to make this 0? It could be from here, it could be negative 3, and from here it could be negative 5. Okay. So I'll put this on a thought cloud because that's not using the quadratic formula. Right? But that would be a valid way to get the correct answer. And that is the correct answer. Okay? So let's try it quadratic. Let's go quadratic with this. Or maybe it's good we did that anyway, just to check the answer. So x equals negative b plus or minus the square root of b squared minus 4 times a. Now a is like 1. Isn't there a 1 right here? And then c is 15. Okay. This is all under the radical. This is all in the numerator. And then all divided by 2a. Okay, just like that. All right, so x equals, okay, I'll just plug that in my calculator. So open the numerator, -8 plus root 8. Okay, and then like, the calculator opens a parenthesis for me. Not all calculators do, but this one does, so that's nice for the radical. Um, -4 times 1 times 15. Close the radical, close the numerator, and then divide by 2. Yep, there's -3. I'll say 4. And then if I scroll over and replace this plus with a minus, yeah, -5. That's exactly what I got by factoring in the quadratic equation of 4 degrees. Yeah, so that's it. So x equals, well, I guess I put them in order and go like this one at -5, -3. Little curly brackets, right? Yeah. Move on down. Number 6. -8x² plus 4x. Now it says equals -5. Is it okay if I just add that 5 over and say plus 5 to get it set equals 0? Okay. So that I have it in standard form set equals 0, and now the quadratic formula is applicable because ax² plus bx plus c equals 0. Got my a, got my b, got my c equal to 0. Okay. So x will be, see, -b, it's -4, plus or minus the square root of b² minus 4ac all divided by 2a. Okay. Now a is a negative value, so watch for the negatives. Careful about that. Now, I'm going to throw in a middle step here before I throw this in the calculator because I forget what the answer is, but I'm suspecting it might involve measuring. I don't know, but we'll see. I'll throw in a middle step. -4 plus or minus square root of. Wait. Oh, actually, you know what? No, this is fine. This is fine. Okay. 4 squared is 16, and then the two negatives cancel. So plus 4 times 8 times 5. Okay. Yeah, okay. 176. Okay, right. I think this one was different because it does come out irrational. Irrational. So there will be like a square root if you want an exact answer. It's all there, -16. Right, so let's see, what does 176 break down to? Let's do a little factor tree. 176 is like 4 times 44, and 44 is 4 times 11. Okay? So 176 is the same thing as 4 times 4 times 11. Yeah, there's your 176 right there. Okay, so I got -4 plus or minus. Now 4 times 4 times 11, I can pull a 4 out. The square root of 11 all over -16. Okay. You know what? While I'm at it, like these numbers are negative. This one's a plus or minus. So if you like, you could do this too. Change this to minus plus, which doesn't really change anything because they're either active or subtracting anyway. Right, so I do see that here. I've got two terms in the numerator. They're both. Here, I can pull a 4 out and divide it down here. So you could go here. I'll pull a 4 out. 4 over 4 times that'd be 1 plus or minus root 11 all divided by. Now, if I pull a 4 out of the bottom like I did right here, I'm left with 4 because 4 times 4 brings back to 16. Okay? This cancels. Okay? So the answer should basically be this. Okay? So 1 minus root 11 over 4 or 1 plus 11 or plus root 11 over 4. So x equals, here I like this, 1 minus root 11 over 4 or 1 plus the root 11 over 4. Okay? This should be my two discrete answers right there. Okay? Now, those are exact answers. If you plug this in the calculator from the get-go, you would end up with decimals. Maybe you could round to the nearest hundredth, something like that, and that might be okay. But if they want an exact answer with the radical, then it would look like this right here. All right. 7, football. A quarterback throws a football to a receiver. The path of the football can be modeled with this quadratic function, where h is the height in feet and t is the number of seconds after the football is thrown. Notice that they frame this is that this equation only tells you how high the ball is, like its height from the ground, which is the same as all these other ones we've been doing. We ran into one that looked like this earlier today. Yeah, the pumpkin jumping contest, we were just focused on the height of the pumpkin. When you guys were blasting balls off the balcony, same thing, you were just focused on the height of the equation you set up. Okay? So here, let's get a picture going. So we got a football field. The football is actually, you know, it's thrown from 4 feet off the ground. Get rid of it. 4 feet off the ground. 4 feet. Which I think makes sense because if the quarterback's a few feet tall and he releases it about shoulder height, yeah, that makes sense why this would be +4 at the end. Okay. So many feet tall. Okay. Okay. And then there's some time in the ball's in the air. The ball is overthrown and the receiver does not touch the ball. Okay. Now, that might look like an extraneous detail, but here's why it's important. Because the receiver is actually catching the ball probably approximately where the quarterback is throwing it. But if he misses the ball does literally go all the way to the ground. Okay? So the ground is true height 0. And that's why you can set this equal to 0 and actually apply the quadratic equation. Set equal to 0. Okay? How long will it take the ball to hit the ground? Yeah. Okay. So got little details in here. I want to point that out to you guys. Okay. So I got height as a function of time equals -16t squared. Okay. This is feet per second squared. I was throwing in units. Plus 45t. This 45 is like feet per second, which is not exactly how fast he threw the ball, unless he threw it straight up. But I don't think he did that. But he threw it at some angle. And if you look at the vertical component, now when you guys did this with the ball launchers, you guys found this angle right here, theta. And you took the sine of that angle to say, well, how fast was it initially traveling? Not altogether, but just strictly in the vertical. And that's what this 45 feet per second represents. And then +4, and that's feet, because maybe he's releasing it from 4 feet above the ground. Okay, does that make sense? And we're going to let this all go to 0 so that the ball can hit the ground height 0, and then we'll solve for this time. Okay, so height is a function of time in general. I'm just letting this go to 0. So the time to hit the ground equals -b plus or minus the square root of b squared minus 4ac all divided by 2a. Like that. Okay. Now, I have a prediction before I plug this in my calculator. I think I'm going to get two answers, two real answers, I should say. Okay. One's going to be a slightly negative number, and one's going to be a large positive number. And the only one that counts is the large positive number, because a small negative number would be like if you complete this parabola backwards in time. It's like, well, the ball could have been at the ground over here, but not really physically. Okay. So let's see if that's true. T equals, so got open the numerator, -45 plus root 45 squared. Here, I got two negatives here. Let's call it plus. Plus 4, 16, 4. Close the radical, close the numerator, divide by -32. Okay. Oh, yep, there's a small negative time. -0.09 seconds. Or, again, that one doesn't make any sense, so I know I'm going to throw that one out. If I scroll over, then minus point. There we go. 2.90 seconds. Okay. Also, that number looks entirely reasonable, doesn't it? Okay, quarterback throws the ball. It's in the air for about 2 or 3 seconds. Yeah, there you go. Number 8. Okay, so all these here just says solve by quadratic formula. So let's go for it. Number 8. X squared plus 2x minus 35 equals 0. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Let's say plus plus. Okay. I'm just going to plug this in the calculator, and if it's a decimal, it'll just round to the nearest 100. So -2, let's start with the plus. Square root 2 squared plus 4 by 1 by 35. Close the radical, close the numerator, divide by 2. I'm getting 5. Oh, so get an exact integer. 4, and then throw in a minus here. -7. Okay, so I can write it this way. -7 or 5. There you go. Okay, someone did come out to, hold on. All right. What was this discriminant here? What is 2 squared plus 4 by 35? Oh, it's 144. Okay, 144 is the perfect square, which is the square root of that would be 12. Hence, we have integer answers. Ooh. Number 14. 14. Got x squared minus x minus 5 equals 0. Okay. Does that look factorable easily? I don't think so. Because what's two numbers that multiply by 5, but add to -1? Okay, there. So quadratic is a great method for this one. So negative b. Now, -1 is like +1. Okay. So plus or minus the square root of b squared, which is always positive regardless, minus 4 times a times c, all divided by 2a. Okay. So thanks before. You know what? Over here. Here. Negative is positive. This negative doesn't matter at all because it's getting squared. So just think of some things ahead of. Open the numerator, 1 plus the square root, and then radical. Uh, Let's wait, okay. No, okay, now I just typed the -1 just for completion, but notice that I squared the entire -1, including the negative. Okay, so here, if you wrote it like this, I want to show you something wrong. If I did this, oh, -1 squared, then it'll square the 1, but then it turns around and makes it negative, and that doesn't work. You get the wrong answer. So I have to group this all together in parentheses there. Or you can know ahead of time that the negative goes away anyway. Maybe just don't even type it if you want to be really safe there. So plus 4 times 1 times 5, close the radical, close the numerator, divide by 2. So I'm getting 2.79, or, and then scroll up, scroll over, minus -1.79. Okay, and those are rounded numbers. That's to the nearest 100. Okay, so if Alex prompted you to the nearest 100, you could type that. If it wanted an exact answer, you'd have to. Here, I'll show you guys what the exact answer would look like. X equals 1 plus or minus square root of, well, this is 1, this is 20, so that's 21. All right, that's all that is, 21. Okay. And then I'll divide by 2. So x equals 1. Now, 21 is 3 times 7, which are both primes, so I can't really simplify this. Whoops, I didn't do that. Okay, so x equals 1 minus root 21 on 2, or 1 plus root 21 on 2. Okay, so that's an exact solution. Okay. So here's rounded to the nearest 100. Here's an exact solution. 17. Got x squared plus 25 equals 0. Huh, okay, now this one looks a little different because where's the x term? I mean, I see an x squared, I see a constant. Okay. Now, you might even be able to get this by factoring. Do you guys remember from maybe earlier this week? Could you do x plus 5i, x minus 5i? Right? So I think this will be imaginary. See, okay, if this was x squared minus 25 equals 0, it'd be even simpler. You just do x plus 5, x minus 5. Okay? You FOIL, FOIL. Okay? But x squared plus something, you're always going to get imaginary solutions. So there's two imaginary solutions. Okay? Let me show you guys this is true. Okay, so here's your solution. I'm seeing this just from the factoring method. From this one, you get -5i. And this one, you get +5i, because that would also zero it out. Okay? So those are the answers, which I can get from factoring. Well, let's try quadratic. Let's go quadratic with this. So x equals -b, which is like -0, because there is no x term. There's an x squared, there's a constant, but there's no x term by itself. So b is 0. Okay? Plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay. So x equals, so this just goes away, whatever. Okay. This is -100, isn't it? The square root of -100 divided by 2. Okay. Well, 100 is 10 squared. So that's like, I can take a 10 out, and I still have the square root of -1. 10 over 2 is 5. I forgot it was plus or minus. Oops. Let me backtrack a little bit. This is plus or minus, so don't forget that. Okay? So this is 10 over 2 is 5, so it's plus or minus 5. And then square root of -1 is I. Hey, look at that. It's the same thing we got by factoring. Right, this is this. It's the same thing. It's the same thing. Okay? The quadratic equation will never fail you. 21. x squared minus 14x plus 53 is 0. Okay, so for x, let's just jump straight to quadratic. Yeah. X equals negative b. Well, negative 14 is not like positive 14. Say plus or minus the square root of b squared. So the negative here goes away anyway, whatever. Minus 4, a is 1, c is 53. All right, a is 1. So that's all in the radical. This is all in the numerator. This is all divided by 2a. Okay. Okay. Let's see what this discriminant is. I'll throw on the middle step. So what's 14 squared minus 4 by 53? It's negative 16. Okay. So this is 14 plus or minus the square root of negative 16. This is all divided by 2 times 1 is 2. Like that. Now 16 is a perfect square, but it's also negative. Ooh. You see how the discriminant is negative? That means we're going to get complex solutions, like imaginary solutions out of this. So x could be 14 plus or minus. Now here I can say the square root of 16 is 4. That's okay, but I still have the square root of negative 1. Okay, this is all divided by 2. So now I could split this up into two fractions. Let me do it. I'm really doing overkill here, but it looks like this. Plus or minus 4. Here, I'll make this square root of negative 1i, because I had to do that at some point. Okay? Yes. Now, this I can reduce. So x equals 7 plus or minus 2i. Or if you like, you did x equals 7 minus 2i, or 7 plus 2i, curly brackets for discrete answers. Right? Anything like that. There you go. Imaginary solutions. Okay. So let's see here. Find the value of the discriminant and then describe the number of roots. All right, so this one they aren't even saying solve on this. They just want to say, can you identify the meaning of the discriminant? So x squared minus 8x plus 16 equals 0. So the discriminant, you guys remember is, well, here, spell out letters, b squared minus 4ac. So in this case, b is negative 8. Now squared becomes positive anyway. Minus 4. A is 1. C is 16. So that's 64 minus 16, 63. Okay, look at that. It's not 0. Right. So that means that there's one real solution. Right? So it'd be a perfect square. Right? Actually, I should have got that from the beginning anyway. Now I see this is definitely easily factorable, isn't it? Guys, isn't it just x minus 4, x minus 4? Like that? Or you could call it x minus 4 quantity squared. Yeah, it just be like that. Yeah. So the only solution is x equals 4. That's it. X equals 4 is the only one real solution. But the idea of the section is from the discriminant. You can see how many solutions. Square root of 0 is just 0. That means you only get one value. Okay. So 26. We got 3x squared minus 2x. Notice there's no constant, or you could say constant is plus 0. If you like, I just added that in because I didn't really change it. Okay, so discriminant, which is b squared minus 4ac. That's going to be negative 2b squared, which is positive anyway, minus 4 times 3 times 0, which is just 4, because negative 2 all being squared is positive 4. Okay, this bit just goes away there. So the fact that this is greater than 0 means I get two real solutions. That's all. Yeah, two real solutions. I think that's all they're looking for there. Okay, 28. Yeah, sorry, fit 28 right here. Got 5x squared. Now there are 0 x's, so I'm just throwing that in myself. That just says minus 6 equals 0. Yeah. So what is b squared minus 4ac? That would be the discriminant, right? Which in this case is 0 squared minus 4 5, -6. I got two negatives that makes it positive. So I think it's 120, right? Okay. But the important thing is that it's positive, which means I get two real solutions. Okay. So 26, 28, each of those I'm getting two real solutions. 35. Okay. Yeah, I was trying to pick out different ones ahead of time. So I wonder if this has a negative discriminant, probably. That's probably why I highlighted this one. We're going to find out. 2x squared minus 3x equals -2. Well, first I have to put it in a quadratic form. So I have to add the 2 over. So I get ax squared plus bx plus c equals 0. Okay. And now the quadratic formula applies. You can make a quadratic equation. You can find the discriminant. The discriminant is b squared minus 4ac, and we're just focusing on that. So there's your b squared minus 4ac. Like this is a and this is c, right? Which are both positive values. Right. Now this squared is positive regardless of positive 9. Okay. And then this is 4 times 2 is 8 times 16. Aha! There we go. That's -7. And the important feature of that is it's negative, or less than 0, you could say. Hence, there will be no real solutions, only imaginary, or they might look for the word complex. Complex can have a real and also an imaginary component solutions. There you go. Okay. 36 through 38. 36, 37, 38. Okay. Describe the discriminant and determine the type and number of roots. Okay. So it brings back to a graph. We're saying like f of x equals or y equals, and then you have something like ax squared plus bx plus c. Okay. Now, if you took that and set it equal to 0, you'd be trying to hunt around. You'd be trying to find where does it touch across the x-axis. Okay. Well, the first one doesn't at all. So b squared minus 4ac. The fact that this parabola does not touch the x-axis at all, whatever the equation is, I know if I set up the standard form ax squared plus bx plus c equals 0, the b squared minus 4ac bit would have to come out to be negative. It has to. On number 37, b squared minus 4ac, well, this parabola does cross the x-axis twice, so this discriminant has to be positive, more than 0. Number 38, ooh, this probably touches the x-axis at the vertex. So again, whatever the equation is, x squared plus bx plus c, if I do b squared minus 4ac, it will definitely come out to 0. I'll do an example for this one. What could this possibly be? Could this be y equals, how about x plus 2 quantity squared? I mean, that in negative because it's upside down, right? Okay. So x plus 2, that shifts it to the right. Okay, square makes a parabola and negative flips it upside down. Okay, I guarantee you that the discriminant for this one will come out to 0. So let's try it out. So I can expand this out. So FOIL, FOIL, that's x squared plus 2x is 4x, 2 is 4, right? And then this whole thing is negative, right? Okay, so that would be like -x squared minus 4x minus 4. That could totally look a lot like that. Maybe if this was like 2 units to the right, I just made something up. Okay? So what is b squared minus 4ac? Right, the discriminant. Okay, well, that would be -4 a squared minus 4 times -1 from here. And c, it's -4. So that's 16. Okay, I have 3 negatives, so overall it's negative. 4 plus 16. Hey, look at that. Right, it is 0, just like I said it was going to be, because the vertex touches one place. I could have made this x plus 3 and worked it out. I would still get 0. Still get 0, I think. Let's a few more here. All right, number 48. Oh, height is a function of time. Is this a, yeah, projectile? Right, so 48, use a model. We got h of t, here, height is a function of time, equals -16t squared plus 60t. Right? it says an object, so it could be firework, maybe it's blasted up at 60 feet per second, and Earth gravity. When will the object be at a height of 56 feet? Ooh, so we're taking this equal to 56 feet. Right? And see if I draw a picture, it could look like this. Right? And it blasts up at 60 feet per second. Okay, and right, and eventually maybe it comes back down. Right? Now, if I get two real solutions to this, that means that would have surpassed 56 feet, but it also comes back down and crosses 56 feet the other way. If I get one real solution, that means it just barely reaches 56 feet. And if I get no real solutions, that means it never reaches 56 feet. So I don't know where 56 feet is in the scheme of things, but I can find out by looking at the discriminant or set up for quadratic. So here, where it's at, this will be negative 16 t we're solving for squared plus 60 t. Okay. Now, since I say equals 56, as in equals 56 feet high, I'm going to say minus 56 now equals 0. And now I can apply a quadratic equation. So, so the time when it would be at the 56-foot mark, I can just solve this. Okay. Set up a quadratic equation right here. So negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay. Now I have a lot of negatives flying around. I want to be careful about that. Maybe I'll throw in the middle stuff, clean this up a little bit. Negative 60 plus or minus square root of. Now, let's see, what is all this? 60 squared. Now there's three negatives, so overall it's negative. Minus 4, 16, 56. Okay, so this comes out to plain 16, so that's nice. All divided by negative 32. Okay, equals. Here, I'm gonna. Okay, I have 1, 2, 3 terms, right? Two in the top, one bottom. These are negative, and this is plus or minus, so I'm gonna get rid of the negative. I'm gonna say 60 plus or minus, and square root of 16 is 4, and it's over 32. Okay. So t equals. Okay. Now notice I'm going to get two positive numbers out of this, which does make sense. It matches my story. Here, I'll get the exact solution. What's 64 over 32 is, well, here, let me try the other one first. 56 over 32. 1.75 seconds. And also, 64 over 32 is 2.00 seconds. Okay, 64 and 32. Okay, there you go. Just like that. Okay. So remember the original story I told you guys is we're blasting maybe a firework rocket like straight up in the air at 60 feet per second. Now Earth's gravity is pulling it down, so it's eventually going to bend around straight down. Okay? And I want to know, when is it 56 feet high? Okay. Now from the outside, I didn't know. Maybe it never reaches 56 feet. Maybe it just barely does. Maybe it crosses 56 feet and comes back down, which is exactly what ended up happening. That's why we're getting two solutions. So it takes 1.75 seconds to get up to here, and then looks like another quarter second to turn around and also reach 56 feet high, but coming down. Okay, so that's it. Okay, so yeah. Okay, so cross those once on the way up, then another time on the way down. Okay, those two times right there. That's it. Yeah, matches the story. Number 51 in geometry, the rectangular box, right, has a square base and a height that is one more than 3 times the length of a side of the base. I think they're saying like 3L plus 1, right? Is that 3 times the length plus 1, or 1 more than plus 1? If the sides of the base are each increased by 2 inches and a height is increased by 3 inches, the volume of the box increases by 531 cubic inches. Define a variable, write an equation to represent the situation, find the dimensions of the original box. So here, I want to make my own picture here. So let's see if I can get this. So maybe I'll call a side of the box X. And if since it's a square base, that would also be X. Okay. Now this height right here, I'll call it H for height. How about that? They said is 1 more than 3 times the length of the base. So that'd be 3x plus 1. Right, like that. All right. So I'll say the original volume as a function of x isn't length times width times height. So it'd be x, and then for height, I'll substitute in 3x plus 1. Right? And see, I could also distribute that. So volume as a function of x. So this is the original box is 3x to the power of 3, and then plus x. That's interesting. Okay. Okay, then we're going to increase each base height by 2 inches and the height by 3 inches. The volume increases by 531 cubic inches. Right. So maybe this is like the original box. I'll call it like box A, something like that. Right? Now box B, right, so like the bigger box B, bigger box, as a function of x could be, well, now the side isn't x anymore. It's x plus 2. So x plus 2. Right. Now that's squared because it's a square base here. So x plus 2, x plus 2. That's where I'm getting that from. And then we said we're increasing the height by 3 inches. Now the original height by itself was 3x plus 1, but this is plus another 3 inches, or plus 4 if you like. That's like 4. Okay. Okay. So volume of box B as a function of x is x plus 2 being squared. And then I have 3x plus 4. Yeah. All right. It's going to be quite a bit, isn't it? Okay. All right. I think it's going to take me a good few minutes to solve, but you know, I started it, so let's go with it. Okay. Because the other condition we have floating around right here. So here, let me clean this up. All right. So volume of B. Right, let's my check, and then I'll write the third condition. They said it grew by 531 cubic inches, which I haven't written on paper yet, but we can do that too. So I'll FOIL this: x squared plus 4x plus 4, and I still have this 3x plus 4. Okay. Right. And then I got like a super foil thing going on. Okay, so this, and this. Okay, there, like a super foil. So volume D is a function of x equals that'd be 3x to the third plus 4x squared plus 12x squared plus 16x plus 12x plus 16. Okay, I can combine some of those terms. I get volume B as a function of x is, I got 3x to the third. I got, this is 16x squared. This is 28x. And this is 16. Okay, like that. Okay. All right, so here, let me write down the important part so far. All right, so this is the original box right here. This is the bigger box right here. Okay, this whole expression. Okay. And the difference of those expressions is going to be 531 cubic inches. Okay. So the volume original of volume of box A is a function of x. So it's very simply 3x cubed plus x. Volume B as a function of x is 3x cubed plus 16x squared plus 28x plus 16. And I know if I do volume B minus volume A, it is equal to 531. Okay. So this right here is like my system. Here, I'll call it system. Okay. So this should be solvable because we said find the dimensions of the original box, so I can solve for x. And once I get x, I can go back to my original picture and get everything. Okay. So if I take this equation minus this equation, it's equal to 531. Let's try that. So volume B is 3x3 plus 16x squared plus 28x plus 16. Volume A, remember I did 3x to 3. No, it's plus x. I'm going to put the plus x over here so it aligns, so that the terms align. Okay, so that's all there. Okay? And see, if I subtract these two, so subtract volume A from volume B, then I get 531, which is this condition right here. So this goes away. Okay. See, like what my starter I was thinking, well, I said x cubed. We haven't had an x cubed yet. That would not look quadratic. But here is where that cancels out. So this will become quadratic. So I have the 16x squared here. And then 28x minus this x leaves me with 27x. Now I do still have this plus 16. And that's equal to 531. Right? But I can subtract over the 531. So like minus 531 minus 531. Okay. And then get z equal to 0. And then we can make a quadratic equation. You get everything. 16x we're solving for squared plus 27x. Again, we're solving for x. What is 16 minus 531? That's minus 515. Okay, now that's equal to 0. Now I have ax squared plus bx plus c equals 0. It's quadratic time. Let's go x equals, set up a big old fraction, negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Things like that. Now, because there's a plus or minus, I'll probably, if there are two real solutions, well, I'll probably get two real solutions out of this. I'm imagining one of these is going to be negative, in which case I couldn't have a negative side physically, so I can throw that answer out. Also, I see a double negative here, so then let's have a little calculator work with it. So let's put this in. Open parentheses, open the numerator. Negative 27. Let's start with plus, see what happens. Plus square root 27 squared plus 4 by 16 by 515. Close the radical, close the numerator, divide by 32. I'm getting x equals 4.892 inches. Right, or if I do minus right here, yeah, minus. Okay. Negative 6.580 inches. Okay. Now the negative one, it's never going to be that. So it's got to be this right here. Okay. So to finish this off, because the original framing of the question is what's the dimensions of the box? Okay. So, well, I know this x is 4.89 inches, right? Okay. So the dimensions are 4.89 inches by 4.89 inches, rounding to the nearest hundred. Now the height was 3 times that plus 1. So we go back to get the first one. Okay, so I had this. If I say times 3 plus 1, right, that gives me the height of the box, which was 15.68 inches. Right? So there you go. There's the dimensions of the original box. Good. So they want to write, yeah, the dimensions of the original box. Boom, got it. 52 games. A carnival game has players hit a pad with a large rubber mallet. This fires a ball up a 20-foot vertical chute for a target at the top. A prize is awarded if the ball hits the target. Explain how to find the initial velocity in feet per second, which the ball will fail to hit the target. And assume the height of the ball can be modeled by h equals negative 16t squared plus bt, where b is the initial velocity. Yeah, that's exactly what we got. So 52. Here, I'm going to draw this out. So this is like one of those carnival games, right? Where they got maybe like if you hit this and then it sends a ball flying up and there's like some height. Right? Maybe this is the target right here. This is target. Right? And this target is, they said 20 feet up. So h equals 20 feet. Okay? And you got like a big heavy ball here. Okay? And you're going to strike this with a mallet. Right? And then you're going to strike like bam right here. And it sends a force and sparks at some speed v, which they also labeled v right here. That's what this v is, the initial velocity. Okay? That's what this is right here, this initial velocity. And see, if you don't hit it very hard, it goes up like halfway and comes back down. If you hit it hard enough, it'll go all the way to the top. Okay? And if you hit it even harder than that, it'll still go all the way to the top. So there's some minimum speed you want to hit. And they're saying the height as a function of time, right, equals now negative 16t squared. No surprise there. If you work in feet, like feet per second squared, that's related to Earth's gravity. You guys have seen that a bunch of times. Plus the initial strike speed times time. Right? Now I could say plus 0 because we're starting on the ground. They didn't type that, but that would be true. I didn't really change it. And I want this height to go up to 20 feet or more. Like if this could extend higher, it could be okay for it to go higher, but it's got to go at least 20 feet, right? It could only go up 10 feet. Then no good. It doesn't hit the target. So here's my quadratic right here. So I'm going to subtract this over to get z equals 0. So I'll say negative 16t. Hang on a minute. All right, let me just. T's. I shouldn't box the t. We're not actually solving for t. The question is more geared towards what is v. So there's sort of like two unknowns, but I'll show you how that's still okay. So negative 16t squared plus vt, and then subtract this 20 over, minus 20 equals 0. Okay, now that is a quadratic equation, ax squared plus bx plus c equals 0. Okay? Now t is just how much time it takes to like reach some height or something like that, right? But what could this v? That's really the question. What is this v right here? And for that, we got to hit the discriminant. So what I'm imagining is that um, if you didn't hit it hard enough, it would never reach this height at all. So I think the discriminant b squared minus 4ac would be negatives because there are no solutions. If it's equal to 0, that's the tipping point where it just barely reaches that. And then if you have a positive discriminant, it could easily make it. So I want b squared minus 4ac to be at least 0 or greater than 0, but it cannot be less than 0. So how does that translate here? Well, here's my b value is b. Okay, so that's what we're solving for. Squared minus 4. My a value is negative 16. Careful with the negatives. And my c is negative 20. Yeah, so there's negatives flying all over the place. That must be greater than or equal to 0 to win the prize. So v we're solving for squared minus, what is all this? 4 by 16 by 20. 1280 greater than or equal to 0. So add that over. B squared greater than or equal to 1280. And then square root. I'll just take the positive value, so like you're trying to hit it upwards. What's the square root of 1280? So B has to be greater than or equal to 35.78. And that would be feet per second with units, right? So if you hit it at that speed, 35.78 meters per second, it'll just barely get to the top. Bing, you win the prize. If you only hit it like 22 meters, or sorry, 22 feet per second, then no good. Won't you make it there. If you hit it like 50 feet per second, oh, easily, right, easily you get there. Right. So there you go. That's what you're looking for. Now, games. And oh, that was the last one I highlighted actually. I'm sure there's lots of other good questions, but I tried to pace these out to about one class hour, maybe an hour. All right, so yeah, we'll hit pause point there. Of course, in class, I'll be walking around answering any of your questions.